Hi everyone, today in Integrated Math 2, we're going to go over Chapter 11, Lesson 1. Here are the objectives. Make sure you write them down in your notes. Alright, so this week we're going to be going over circles. The first thing we're going to go over is circumference. Circumference is the distance around a circle. It can also be thought of the perimeter of the circle. Okay, so the distance all the way around it. The next thing we're going to be talking about is a chord, which is a segment connecting any 2 points on a circle. In our case, we have P and Q, and those will make a line segment, which is also known as a chord. A diameter is the largest chord in the circle, and it passes through the center of the circle. So notice the difference between this chord and this chord known as a diameter. It's the location of it. And then we have the radius, which is half of the diameter. So now we're going to look into circle pairs. Two circles are congruent if and only if they have congruent radii. And radii is just the plural form of radius. Okay, so here we can see that radius GH is congruent to radius JK. Because of that, we can say that circle G is congruent to circle J. This symbol here is just simply means circle. Our next circle pair key concept is that all circles are similar. So notice here they are not congruent because they don't have the same radius. However, we can say that they're both similar. They're the same shape. They're all circles. So circle X is similar to circle Y. Next we have concentric circles, are coplanar circles that have the same center. We have circle A with radius AB. And we have circle A with radius AC as well. And because of that, they are concentric because they have the same center, which in our case is A. Alright, next we want to go over intersection, specifically points of intersection. So when I'm saying 2 points of intersection, I'm saying that the two circles, they cross at 2 points. 1 and 2. And once again, they cross at 2 points here. There's 2 intersections, 1 and 2. If it was 1 point of intersection, it would only cross once. 1. Once again, only ever cross once, so it's 1. Notice here, they are never going to cross those circles. They can have a circle within a circle that still leaves no points of intersection. Alright, so in order to find our circumference formula, we're going to start from the beginning. Circumference divided by the diameter, which is also equal to pi, which is also known as 3.14159, and this repeats forever. It has no end. Alright, so instead of writing circumference every time, I'm going to use the letter C. And instead of writing diameter every time, I'm going to use the letter D. So C divided by D is equal to pi. Then I want to find out what the circumference is. So think about this like we're boxing our C to get it alone. I want to multiply D to both sides. So that goes away. C is equal to pi times D, which is the diameter. Okay, so our circle, in any circle, this is our diameter. But I don't want to use diameter, I want to use radius. Well, radius is when we have the diameter split in half. So this is R and this is R. And if we add our R's, we have 2R. That is equal to D. So 2 times 2 radiuses equal the diameter. So I can replace that. I can use substitution. C is equal to pi times 2 times r. And I simplify that, and that is C is equal to 2 pi r. And that is our formula for circumference and where it comes from. So for circumference, if a circle has a diameter d or a radius r, their circumference c equals the diameter times pi, or twice the radius times pi. So we solved both of these equations. C is equal to pi times d, d being the diameter, and c is also equal to 2 times pi r, r being the radius. These both can be used. It just depends what kind of information you have. And you can see from our previous slide here that you can always do this yourself in case you forget what the formula is. A polygon is inscribed in a circle if all its vertices lie on the circle. On being the key word. It does not say in, it says on the circle. A circle is circumscribed among the polygon if it contains all the vertices of the polygon. So in this case, quadrilateral L, M, N, and P is inscribed in circle K. Notice the vertices all lie on the circle. And circle K is circumscribed about the quadrilateral LMNP. And there we go.